Hi guys, so far we learned about classes, creation of methods, how to debug and how to run a particular method. Now it is too difficult, like we can't keep on running, and as you could see it actually bloats up the entire file. So that is the reason why we need to go for Scala test. Okay, as you could see I just created this method. Right, so where I just added a dependency called ScalaTest. If you are confused, you can just search for the ScalaTest in mavenrepository.com, and it would automatically provide you the location and the URL. You can just copy that URL and keep it here. The dependencies would automatically get added. Okay, so today we will learn about data structures and how to do testing in using ScalaTest. Right, so I just created a simple linked list. What I have done is like I created a small so this is what you have to learn, guys. So this is how you can templatize a content. Let us say if you take linked list or a list, or what do you say, like trees, maps, or anything. So those are kind of generics, right? So in order to define a generic, like it works whether you do it for int or any object. You just need I mean that rule would be like kind of standard. That is the reason I just created a linked list, and this is how you can templatize it. Whenever you templatize it this way, so as you could see, you can the way you implement it is like list and new list of kind of string. So then it holds all the details of the string. Right, so that's the advantage of using a template or a generic. So where you just define something, put it in square brackets, and it actually takes the entire value. Now let's look back on what I have implemented with linked list. Right, so I just created a node where I specify that in a node I just want to take a value. You know what? Let's not. Yeah, so just leave it like that. Okay. So let us say I just created a node which takes a value as we learn about the structured things. So I just defined a variable called value. I just considered that as an input parameter. So this is how I created a constructor class and named it as node, right? And it possesses another variable called next. So in linked list, the way we do stuff is like every node will be pointed towards its next node, right? Like that is why they call it as linked list, because you are linking your header node. So they call this node 1 as the head node, right? And head node to node 3 and blah blah blah. So like that, you are kind of extending it. Now let us see how you want to add. So what you need to do is, this is like initializer. Let's put some comments here. Node to hold data. Okay. And yeah, hold head of the data, head of the linked list, right? Yeah, so when you are doing this, so this is good and this is good. So nice. So we just have a head, and then what we are doing here is, let's write a null add statement here. First you are checking whether header is equal to null. If the header is not initialized with any value, or first time you are adding a value, then yeah, so you are just placing the value. You just initialized it with a node, right? And you provided the value. So by default what it will happen is, it will just create a node and value would be set, and the next node is equal to null, and then you are returning the statement, like for the first time when you don't have any records. When list is blank. Now when you have records, what you are doing is you are setting your current node to head, and you keep iterating till current dot next is equal to null, next not equal to null. So the advantage with this is, like, once the next value is equal to null, it will actually stop, and then you are iterating over. So that means you are just checking, like, from head you are moving if it has a next element or not, and then if it has a next element, then you are putting current to a node, and then you checking if node 3 exists or not, like that it you actually come across. Now let us see if node does not have a next. So when if it is blank, what will happen is it will just initialize this current dot next to a new node element, right? And then you are setting the value. That means you are setting the value. You are just writing here stating that, okay, this is node 4 and I'm setting the value. So the very moment I set the value, again it's a node 4's next becomes null. This is, guys, you are kind of adding all these elements, right? So, and then let's not create a drop object. Whereas what we can do is we can just create a length, or let's write an iterator to read through, or let's define something like print list, right? So now what you're doing is you're just defining a new method which actually prints the entire list. Okay, all you are doing is yeah, so in this print list, what it does is, like, it should start with a node, right? So again, while um, current not equal to null, right? I'm just starting with where current is equal to head, while current not equal to null, right? So println current. Okay, and I want to write a test to see if add value is working fine or not, and it is actually printing this particular list, right? Or you know what, I just want to yeah, so I just want to read. Okay, we'll write about iterators later. Let us look at creating print statement. Earlier I used simple main to do all my tests. Instead, what I can do is I can just create a method to test my linked list. Okay, so make sure, guys, like, this is the standard practice that people follow. Make sure the package name is same to that of that class that you want to test, so that way you know exactly where these particular elements are. And then new Scala class, so name is same to that of linked list, and then you just end it with capital test. Now add it. All you need is you need to extend it with flat spec. So there are a lot of things that are available, but I'm actually going to use flat spec. Yes, guys. So when you extend it with flat spec, this is how you have to write your test cases. What you are specifying is you are specifying linked list add should add an element to the list. Okay. So the end in statement is what you just need to extend it with flat spec, and you need to add linked list. Guys, linked list is a quite generic term, so that is why I have to explicitly specify that this linked list. Now let us just uncomment this. When I create this linked list, as it is showing, like, click hover on that and click alt enter. So there are 3 linked lists available, right? So but you wanna take the linked list that we just created. So I just put it over here, right? So that's why make sure you taken our linked list, right, which has our add method. Now all you need is linked list dot add. As you could see, you are able to uh, give header also over here, but if you give header, people can actually change or modify a lot. What I would rather recommend you guys is just make sure it's not let's make it as private. And similarly, this node class, you don't need to expose it to outside world how we are doing stuff. So make sure you keep both of things as private. So private means these things can be accessible only within this class, but for the outsiders, they will not be able to extend it, right? So now linked list of strings, so I can add anything. So let's start with India, right? I'm able to add. It is not throwing any error, so make sure linked list, or let's implement a simple method whether a linked list has an element or not, right? So I just let's create another method where I'm just defining has element, right? And it should actually return a boolean. If since head is like the first element, if it is null, rest of the things is null. If head, I'm sorry, double is equal to null. Okay, then return false because it does not have any element. Else, okay. So now if it has an element, so whenever you add a linked list, you need to make sure it has an element. So there is something called assert where you can specify the condition. All right. So this is what we are using. Linked list has element. So this is how I'm actually conducting a test. So linked list add should add an element to the list. So what we are doing is we just create a blank element. So by default, it should not have any elements. So assert condition not of linked list has element. So first we need to make sure whenever you create a blank linked list, it does not have any element, so it has to throw error. And once you add an element, it should have an element. It should have an error. It should have a element, right? So this is what our test is. Now right click here, and then you can use run. As you could see, again, compiler is compiling the content. Once the compilation gets successful, it will actually so one test pass. Since there is only one test case, you are making sure like that particular test is kind of passed. So this is how we actually like add these speculations and add these elements, right? So to do more stuff, like let's implement new methods into our linked list. So let us take linked list. Let's create another method called iterator. Oh no, first of all, let us see if print statement is working fine or not. So we need to make sure even the print statement is working fine. So just to make sure like these elements are already there, you go back to our linked list test and then Yep, so linked list dot print list. So it should actually print a list. Again, let's rerun the content. Yep, so somewhere it's actually, let's stop this. I think somewhere it is getting into some reverse or looped structure. Now let's go back, go to our print statement and see where it went wrong. Yeah, so this is the thing, guys. I just placed where current not equal to null, but I didn't even just iterate it to current is equal to current dot next. Since I didn't do that, it kept on printing the header value, and since header is not null, it kept on doing it. Yeah, so this is one good thing, that using test you could even test all this stuff. So run. Though we had written test for add, but I think we kind of tested println statement. So I think I should not actually, I have to print it. I should not actually print a node. I should actually print the value of node. So go back here and in our print statement dot value, right? So now again, let's rerun. Yep, it works. So it printed India. Nice. So now what we'll do is let's create an iterator, because you created this header node, and you need, like, you can't keep printing the statements to evaluate. You need some guy where I can iterate a node, or I should be able to get a node at a specific location, right? So let's start with getting a node at specific location. Come back here. No, not here. Yeah, so here I just defined a method. Here what I specified is like, just use get, right? So get, it should actually get you the value. Guys, don't ever expose next, because get and return type is actually T, right? So this is how you define the template, and it expects an integer. Let's call it as index. Now here are the things, guys. So let us see if I have two values, and if I'm trying to get more than another element, then it should actually throw error. So what we'll do is, whenever you add a particular element, you need to make sure, like, you have length, and if I'm actually accessing something which is bigger than the length, it should throw an error. So what we'll do is, we'll just create another variable, right? So as you see, this variable, let's create a variable called length. But yeah, so guys, this is where you have to make sure you use our private key, right? And I'm specifying that this is length. Guys, in this length, I just want to expose only the what do you say? So I just want to expose only the length of that particular value. So only get I'm actually allowing, but not yeah. So private var underscore length. As we learned about getters and setters, user should not be able to set the length of this particular thing, but he should be able to get it. So this is how we kind of defined our get, right? So where length, which is again, since it's a property, length is equal to underscore length, right? So that means for setting of the value would happens internally. Only the get of the value you could actually just verify it. Okay. Now, so whenever you add an element, make sure your length is actually getting added. So at last, all you need to do is underscore length plus plus. Yeah, so you know what, plus or equal to, yep. You know what, so just avoid all this. Let's put it in a nice way, like the easy way. Okay. So length, I'm actually adding it to plus 1. Now whenever somebody asks for get, right, so I need to make sure this index should not be greater than length. If index is greater than, yeah, so you could use any of the things, right? An index is greater than length, new exception. You can create your own type of exception, but for the time being, let's not worry about it. So there is something called out of bound exception that also you can write. You can give index out of bound exception, right? So now else, this is when you will actually keep iterating up to element n, right? And then you throw the statement. Let us just call it as sorry, right? And then if not, if the index is within this particular length, so let us say like we are starting everything from 0, right? Now that we are starting everything from 0, so index has to be greater than, or else, you know what, let's say like the first index is 1, and like that it actually goes. Okay. And now, yeah, all you need is you just need to run a for loop, right? For I from 1 to index. Okay. Where x, right, from 1 to index. Okay. let's start with where current is equal to gain or head. Current is equal to yeah. So there are several ways you can write for loop, guys. So for I, right, which takes from 1 to index, right? So current is equal to current dot next. So if it is 1, it stops at like 1 to 1. So you are at that particular location. It actually stops at head. And okay, you know what? You just need to do index -1. Yeah. So whenever all you need is just return current dot value. So this is how you had written this get statement where you are, so just in case if you want to know like how to write for loops, there are so much documentation available. So this is the site, like, yeah, so there are several ways in which you can write your for loop. So I don't want to, I just want to skip that. You can just Google for loop in Scala, so you will get a lot of documentation on that. Okay, so now I'm returning this statement get, and yeah, it should actually get this particular value, or it would throw this error, right? So this is how I'm actually looping it. The order of this element is like it should loop through like an index. Is the order of it would be like the index order, because I'm a kind of iterating it with both the indexes. Okay, so this is how I had written this written state. See whether it is working fine or not. So let's go back. Let's create our test case. Linked list get should get the element at given index, right? And this is how you are actually testing it. Again, I created a new linked list, right? And then yeah, let's add couple of values to our linked list. Dot add say India, US, okay. First, let's try printing these statements. Linked list dot print list. First, let's verify that it is working fine, and once it works fine, then we can see when you can assert the values of get. Yep, it is printing correctly. Now let's remove this. It's not required. All you need is you need to assert linked list dot get say index 2 dot, it should be equal to US, right? See if the assert statement works. Let's run it. So it came true, my second index. Okay, let's try doing something wrong. So far I just created all positive use cases. Now let's run this negative use case. See what will happen. So I'm actually asserting for a wrong value. This is just to test, make sure whether our test case is working fine or not. Yep. So what it is showing was false. So this particular expression, get1 was actually false, right? So, but you just want to assert that index of the 2 has to work, so it's working fine. So what we have done is like we created this getter, and let's try removing an element. Right, so let us say I want to remove an element at a particular index. Yeah, so this is interesting, guys. It's not like a normal reference, so I'm just copying this entire code because yeah, if it is whenever you want to remove an element, let us say you want to remove this node 3, right? So if you remove this node 3, the way it should actually, the outcome would be like header node 2 to node 4, right? And again, like whatever you have under these nodes, it should actually go and work fine. Okay, so for that you have to understand that you need to make sure like the next, so then what you need to do is you need to keep the next of node 4 to its parent, and that's it, and it should automate, you should actually drop this guy, right? So whenever you are looping it, all you need is yeah, so with this I can actually get the current, right? And but I need to make sure I have to get my parent as well. Okay, so and guys, one interesting thing is like if somebody asks you to remove a header itself, right? So then make sure like, yeah, it should not return any statement, so remove this guy. Okay, it should not remove, but at the end what you need to do is you need to make sure this dot, or yeah, length, it should be equal to underscore length minus 1. Okay, so don't forget to do this. This you are doing, yeah, anyway, when it throws an exception, it will not even come here, so that is fine. So this is still fine, right? And yeah, all you need to do is if somebody wants to remove the header, then it's a different case. You need to change the header to its next value, so that would automatically drop the element. Okay, so before you get into this loop, all you need to do is yeah, so if index, right, double is equal to 1, that means if your head is equal to head dot next. Okay, else that is where you're running this element, control X, right? So what we do is, right, so whenever I'm going to that particular index, you need to make sure you have to keep the index parent as well, right? So all you do is where parent is equal to head and current is equal to right. So what we are doing is here you are setting two elements. I'm setting parent to head and current to head dot next. And when you loop, one is anyway taken care. Let's start with the two, because one, if index is one, we have anyway taken care of it. So current is equal to current dot next and parent is equal to parent dot next. Otherwise, if you think that yeah, it is unnecessary to hold more variables, then you can just drop this guy, right? So control C, parent. Now I'm looping through parents. I go up to index instead of going up to the last index, right? So I just want to loop it up to the one just before it. Okay, so we missed two guys, like uh, yeah. So whenever I do that, parent is equal to parent dot next. Now that I got the parent of that particular index, right? So not the index, I got the parent of that particular index.